Hi, everyone, and welcome to the Research Like a Pro with DNA question and answer series. Today, we are talking about which WATO, what are the odds, probabilities are best. There are two sets of WATO probabilities, and the first are the 2016 probabilities, or the original ones used in the WATO tool. And then later, there are the 2020 probabilities that were originally introduced in the version 2 beta and are now incorporated into the WATO Plus tool. And you can switch back and forth between these two probabilities. So how do you know which probabilities to use? The original question came up in our Facebook group, Research Like a Pro with DNA, and the person asking the question said, looking for opinions on the accuracy of beta. I am trying to evaluate whether a man is my grandfather's half brother or another relationship. I'm using 12 matches. 3 are on my generation between 181 and 127 centimorgans, and the remainder share 169 down to 31 centimorgans. And 7 of them are not my generation, but once removed. The original probabilities have a score of 427 for the half brother and 1 for the first cousin, and all other as 0. So those are the scores that the original probabilities gave. The beta probabilities show the half brother score as 1 and everything else as 0. And the first cousin is a million times less likely. So, more background information. My grandfather's line has dotted out. The potential half brother has 1 living male descendant, and I am conflicted on whether or not to attempt to convince him to do a Y-DNA test. So, potentially, the answer to this question will help decide whether or not more testing is needed. So let's dive into these two probability sets and try to figure out which one would be more helpful for this question. So WATO is a tool at DNA Painter. WATO stands for What Are the Odds? And basically what it allows you to do is hypothesize about how a DNA tester might fit into a known tree based on the amount of DNA they share with people in the tree. So going back to our question, this person is trying to evaluate this man, this DNA match, to see if he is fitting into her known tree, maybe as her grandfather's half brother, or maybe as a cousin or something else. Now at DNA Painter, there's the two tools that you can use, the original WATO tool and then the WATO Plus tool. The new WATO Plus tool includes a bunch of new features for layout and structure and adding in age probabilities and a bunch of new features. One thing that's good to note is that even if you're in the old tool versus the new tool, you can use both sets of probabilities. Both of them have the option to switch back and forth between the 2016 probabilities and the 2020 probabilities. So Leah Larkin has several blog posts at her website, The DNA Geek, where she goes into all of the science and the math behind the probabilities. And she explains this. So I'm drawing this information from her explanations. So if you're interested in learning more, definitely go to her blog post called Improving the Odds. This blog post here, Improving the Odds, is where she talks about the original probabilities and then the updated probabilities. So she says that the original WATO tool used the probabilities from the 2016 Ancestry DNA white paper. And one main limitation from that white paper is that their probabilities in that paper and the graph only went down to 40 centimorgans. So Leah used educated guesses for matches below 40 centimorgans in the original probabilities. So the way to read this graph, which Leah took from the Ancestry DNA white paper and then turned it on its side and just modified it a bit to illustrate. But basically, the way that it works is that on the x-axis, we have the amount of DNA. So going down from over 3,000 down to 40 centimorgans. And then over here, we have the probability of different relationships. And the lines, the colored lines represent different relationship groups. So it's not just one relationship group for all of these below half siblings. Parent is just one relationship group, parent, child, and full sibling. But the rest are groups of equivalent relationships. So half sibling and like I think that one is also aunt, uncle, and grandchild, grandparent relationships. So that would be like the green. And then the red first cousin half nib, which is like niece, aunt, uncle, niece, nephew, aunt, uncle. So basically, these lines represent equivalent relationships, so relationship groups. And so what you do is you put the amount of DNA that someone shares with another person on this graph. And then when you draw the line up, you can see all the different relationship group possibilities. And that's where the probabilities come from that are used in what are the odds. So it crosses this green. So if you have between 200 and 500, that would be like 350 would be in the middle somewhere. So if you have 350, it would cross the half sibling grouping and the first cousin once removed grouping and the second cousin grouping with the one that's the highest. That's the most likely relationship grouping. So the second cousin and equivalent relationships would be the most likely for this amount of 350 centimorgans. So, but these other ones are also possible. So that's what the Ancestry DNA white paper gave us, and that's what Leah Larkin used to create the probabilities in What Are the Odds? And then in 2019, Ancestry added probability tables when you click on the amounts of shared DNA. So we talk about this in the Research Like a Pro study group and how you can click on that and see the different probabilities. So it looks like this. You click on the amount of shared DNA in Ancestry, and then you open this, and then you click frequency of relationships, and it gives you this table with all these relationship groupings and the probability or frequency that people who share 461 have this relationship or a relationship in this group. So this is the first cousin once removed group. So going back to this, it would be the blue group here. And so for 461 centimorgans, that is most frequently going to be this grouping. And so these new probability tables at Ancestry DNA were great because they go all the way down to 6 centimorgans instead of stopping at 40 like the white paper did. So to get information from those tables into a set of probabilities, Leah crowdsourced the information from the tables to use in What Are the Odds by having people fill out a survey for information in their match list. So in the survey, you put in this match shares 461 and the percent or frequency, the probability or frequency for that first relationship grouping is X, and then you fill out the survey. So basically getting the table information for all amounts of DNA into the probabilities. So the new probabilities includes data all the way down to 6 centimorgans. And this graph that Leah shares on her blog post, Improving the Odds, shows the new probability distributions, which are the solid lines, compared with the old, which are the dashed. And so we don't really need to go in here and like really memorize this. Just know that the information between the old and the new is very similar. See the lines very close to each other, but some have higher peaks here and lower here, and so a little bit of a different range there. The three main differences that Leah points out in her next blog post that I drew from, a major update to the What Are the Odds tool, she points out the three differences, and she says that the data goes below 40 centimorgans, which we already kind of mentioned, and this means that you're going to have a little bit more higher of confidence using smaller matches, but it probably won't affect the hypothesis rankings much. And that's because any matches below 40 centimorgans just are going to have so many possible relationships. But these distant matches can rule out higher relationships. So that is really helpful for the hypotheses and for the WATO tool. So for example, a 20 centimorgan match is going to rule out the possibility of those people being a first cousin once removed because it's too low. Another difference is that the peaks are shifted downward in some relationship groups, and the effect is not that much for closer relationships, but it is more noticeable for the second cousin and more distant relationships. And then broader distributions, and this one has the biggest effect on WATO. And this broader distributions means that some relationships that were impossible in the original probabilities will now be just a little bit possible, barely possible. And this has a really big effect on the hypothesis scores and can lead to really misleadingly large scores for the most likely ones because you have this small, very unlikely probability for the lowest hypothesis. And so what happened is that with the new WATO Plus that they released, this filters out extremely low scores. So if you're using the new probabilities, the 2020 probabilities, then it will filter out the really low scores, the ones that are less than a million times or more worse than the best hypothesis. So hopefully that helps understand the question. There's one more place to look for information about this question, and that's in the frequently asked questions. And we'll review that in a second. But let's go back to the original question from the Facebook group. So one thing that was confusing for this question asker is that the beta probabilities were showing everything else as 1 million times less likely. So they have been ruled out. So that goes back to what happened here with the new probabilities having the broader distributions affecting the hypotheses to have some misleadingly large scores. So to not have those really, really large misleading scores, it's filtering out those really low, less likely ones. So the less likely one, basically the first cousin, is so much less likely that it's completely been ruled out. So now the only one that's possible is the half-brother score. So what this is telling us is that it's so much more likely to be a half-brother than the first cousin that we don't need to even consider this first cousin relationship as being possible. So the original probabilities also gave us the same answer with the 427 score being so much more likely for the half-brother and the first cousin being 1 as being possible. So basically, both are giving us the same answer, just in a little bit of a different way. And so it sounds to me like maybe the targeted testing isn't probably needed because both of the probabilities are telling us that the half brother is really the likeliest and really only the possible answer. So going on to these frequently asked questions at DNA Painter, it talks a little bit about what people are seeing with which probabilities are better. It talks about how the 2020 probabilities handle close relationships well because of those broader ranges. But for low centimorgan amounts, the 2020 probabilities seems to favor close relationships more strongly than it should. And so if you're using a lot of small matches, you might want to switch over to the 2016 probabilities. And so just in anecdotal evidence from people using the tools, they're seeing that it makes more sense, the probabilities given in the 2016 tool. With close relationships, the ranges are a bit tighter, making it less useful. So for close relationships, use the 2020 probabilities. And one thing that they built into WATO is that if a tree has more matches under 50 centimorgans and it's using the new probabilities, there will be a message that pops up suggesting that you switch to the 2016 probabilities. So it's a bit counterintuitive because it seems like having more data for under 40 centimorgans would make the 2020 probabilities more useful. But it really is going to come down to just practicing with it and understanding how it works, reading the blog posts and the frequently asked questions, and just trying to get an idea of how it works so that you can apply it better to your data. And the overall conclusion here is that while we have this data, the data isn't perfect and it's always being refined and getting better. So we have to take all of these hypotheses and predictions with a grain of salt. And of course, more data is always better. So if it is possible to get more testers and it's not too difficult, then that can really help refine the answers to our questions. And so while these tools can give us really good hypotheses and point us in the right direction. They aren't the final answer. And what we can use WATO for is to point us in the direction of more testing so that we can get a more concrete answer. And really, the best way to get a concrete answer is to rule out the other relationship possibilities through additional testing. And if you can do the additional testing, then that's best. Hopefully that helps point you in the right direction for more information on WATO and the probabilities. And as we go forward into the future, I think these will get better and more refined as we use them. So I hope that helps.